So hello and welcome to this SDC Verifier webinar. Today we are going to discuss new features of SDC Verifier 2020, which has just been released about 2 weeks ago. Plenty of you have already downloaded the new versions, updated your licenses and tried some. If you haven't done that yet, please do so. The new version is already on our website. My name is Oleg Ishchuk. I'm the Chief Operating Officer here at SDC Verifier, and today I'm joined by Bogdan Melnik, who's our leading software developer. He took big part in developing this new feature, so he's one of the best guys who can present that to you. And also our marketing manager, Petronek, is here with us, and he will help us he will make sure that everything goes smooth and the connection is good, everybody can hear me well, and it's going good. So we released the SDC Verifier 2020. It brings a lot of new features to the users, and we're going to present and demonstrate them today. I assume that everybody who's here have already some experience with SDC Verifier, or at least have an understanding what is the idea behind the software, what is the purpose, and what are the general capabilities which are available, which were available before. So today we will focus on the new stuff. We won't going to do the introduction. If you lack that, if you miss some understanding of what is the main capabilities of the program, please visit our website or YouTube channel, check out the previous webinars recordings, check out the introduction or tutorials, or if you still have questions, don't hesitate to ask us and to address these questions directly to me or my colleagues, or support at sdcverifier.com. So we're going to jump directly into new features, but I would like to start as usually with this circle of workflow with SDC Verifier, because now it has a significant change. So we not only work with your FEA model, helping you to combine the loads according to the standard prescriptions, helping you to recognize the structural members of your FEA model for further code checks, doing the checks themselves and helping to document all that in extensive reports. Now we also have an optimization tool. For the moment, it works with 1D elements and gives an opportunity to automatically pick the best possible design decision based on code checking results and use this chosen decision for the future calculations. So now SDC Verifier is not only verifying your model according to the standard and saying you're okay or not according to Eurocode or AISC rules, but also if you're not in the range you would like to have, or if you have some overshoots, you can select the parts of your model or complete model and optimize that and see which cross-section is going to pass the results of the standard. I'm going to, sorry, I saw some question in the chat. Petro, can you help me with that? Chat box. It sounds like Michelle has no audio.
No, I can't see any questions in the chat. Maybe it's directly.
Yeah, I see a private. Yeah, I see a private question that Michelle cannot hear me. Can anybody else? Do anybody else has problems like this? Can everybody hear me? Petro, you hear me well?
Yes, I hear you well.
Okay, then seems like it's. Yeah, Aryan also can hear me. So seems like it's something on your side. Anyway, there will be recording in the end. There will be another session today at 4 p.m. Central European time. So please attend that or try to download the recording afterwards. Yeah, sorry for interrupting. So let's get back to optimization tool. It gives you an opportunity to pick the best possible design decision based on code check results. So now SDC Verifier is not only saying if your structure is built directly according to the code. Is it okay or not according to the code? But if it's not okay, you can run the optimization tool and pick another design which is going to pass the rules of the code. I'm going to focus on this today. I'm going to make a demonstration how it works. So this will be a main point, but also there's plenty of other new stuff, and we're going to quickly go through most important features that has been added. So first of all, we always trying to keep up with the latest releases of FEA software. New SDC Verifier 2020 works with ANSYS 2020 R2, SimCenter FEMAP 2022, and SimCenter 3D 2020.1. And now we are also named not with 5.3 as it was before, but now you will work with SDC Verifier 2020. We hope it's going to help you to avoid some confusion, and you will understand in that you're working with up-to-date version of the software. Let's start with standards, new standards that has been added to SDC Verifier. In this version, we added 2 new fatigue standards. It's FKM, Analytical Strength Assessment for fatigue, and DVS code for both aluminum and steel fatigue, which is commonly used in railway industry, and we had plenty of requests to develop this standard. I hope your requests are fulfilled now, and I'm going to show you how that works. Basically, as all the other standards, it's starting with a wizard, so I will make a short demonstration of that. I'm going to present this one in FEMAP, but as you know, all the features of SDC Verifier are the same for ANSYS, SimCenter 3D, and FEMAP. Demonstration of the optimization tool will be made in ANSYS. So this is the main window of SDC Verifier 2020. Some new icons, few new tabs, but in general looks the same. Big change is that optimization is here now. But optimization is a separate module, so it's not available in your standard package. It comes with an extra price. So if you're already a customer and you would like to try optimization, of course, we can give you a trial for that. If you would like to extend your license with optimization, please contact me after this webinar or whenever you're ready. So let's go back to the new standards. We're going to show you fatigue. So to do the fatigue calculation, as usual, we have to do the recognition of welds. Sorry, this is a wrong window, this one. Let's start with Welds Finder and show you how quickly it works with recognition of welds. We see that we have a model of 40,000 elements, 37,000 nodes. And basically, to find all the welds within this shell model, we need to do only one click and press the button Find. It starts to analyze the model, and I assume it's going to be about 5 to 6 seconds. So if you have a million finite element model, it's still going to be about a minute, not more. We see some warning here. This is because SDC Verifier not only do the recognition, but it's also checking your model. It's also verifying if the mesh is correct in this welded areas. There could be possible mesh disconnectivity, so nodes are not merged, or for example, different parts of weld are having different lengths, or both of them are recognized as welded. So we have 3 or 4 areas like this. Before verifying the weld strengths, especially, or fatigue, I recommend you to review these areas. Very likely that there is just mesh disconnectivity or not merged node. For this, the demonstration, we're going to skip it. I'll just show you. So we have basically all the welds recognized. I'll just highlight them and press preview button to show you how that works. Basically, you see our model that represents kind of a boom of or jib of a crane structure, and we can put on the fillet edges, so you'll see the mesh. and you'll see how the welds are recognized. Okay, after we have done the recognition of the welds, we are ready to jump directly into the fatigue checks. So everything as usual, you go to standards, execute, right click and go add. Here is all the library of the standards available for SDC Verifier in SDC Verifier. Let's start with the FKM. It's more extensive. We usually try to recognize as much as possible required data automatically. So we define the material automatically or read it from the FEA software properties. We define the welds, we define thicknesses, factors, and all the things automatically. But FKM is quite an extensive standard with lots of rules and lots of options. So here is a list of parameters you have to define. First of all, it's important for FKM to define if your model source is drawings or standards. You can define that. Press apply. You can define it separately for every material. You can put it one for the full model or make different if you have different materials. Then we have this case type. All the parameters has a description, so you can see where it's taken from, and if you have no idea of where to take this parameter, you go directly to the standard and preview what's in that table and define is it case 1 or case 2. I assume that there is experienced FKM users, and you probably know better than me how to define all these parameters, but we will go through a few of them. There is like material roughness, there is a type of material setting, so you have to define, do you have non-alloyed structural steel, for example, go with that. And yeah, roughness of the material, by default it's 1, but you can adjust it. Utilization classes, kind of material, once again, and all these things it's necessary to be defined by the users. We also have constants and factors, which are set for one, all of them are set for 1, but you see here a chapter when you can read and adjust it if necessary. And of course you have to define the FAT class and set the FAT class for your welds. I'm going to show that on the DVS standard as well. So basically, standard wizard for SDC Verifier standards, you have to define some options and constants, make a selection for a rule, define the yield and tensile for the material, or read it from, or it can be automatically read like here from the VMAP. And basically press OK, and you have the rules of your standard created. But let's quickly also take a look on DVS and on DVS for aluminum and fatigue, so and steel, sorry. DVS is over here. We have both standards with one wizard. So what you can do, you can just check or uncheck. If you need aluminum, you select this checkbox and you have some options to define for aluminum check. If you have only steel, this is this requires much less classifications to be set by you. You define the normal stresses phase. By default, it's 1. You define the material type. So it's we have S355, apply. And you need to define the weld. So after we did the weld recognition, we just need to set a weld class. For our full model, we define it as A+, which I believe means it's non-welded. And then we add another criteria. There is some change, small change in how to define how to select the welds for this classification. You can easily select all welds, and for all the directions set, let's say AB, for example, and you will have a full model A classification and all the welds AB. This selections, so next selections overwrite the previous one. So if I'm going to create a new one on top of that, so it works as it worked before. We can go also to welds, and there is more weld rules. You can select weld by rule, and add also weld intersections or weld tips or weld exceptions and so on. So for example, I would like to have weld ends and intersections and tips, and for those to define some other classification, AB plus or something like that. Selects, it means that full model will be A, all welds will be AB, and then weld intersections and tips will be assigned to AB plus. After that, we press OK. We can add or remove or edit this classification, so we can remove these intersections and still add the set the classification and run check. Here we select the entities to be checked. Materials are already defined from VMAP. We press OK. Standard is added. As well as usual, all the standards are open, so you can edit, select edit and preview the formulas. All the formulas have descriptions, where it's taken from, what does it mean, and if you need to see some intermediate results or see how it's calculated, you can go to create expand table and see the detailed results on every element and so on. And of course, to add a picture or a table with results, you right click on the check and let's select the criteria plot and run this fatigue analysis. I assume it's not going to take much time. We're already 20 minutes in this webinar, and we will go to the next feature. Okay, while this plot is preparing, we will go to optimization. So once again, plot is already done. So the criteria plot for all entities with the proof of fatigue strength parameter is plotted. And you can see over here that on welds, you do have a bit worse results. I didn't select, I just selected AB class. If I select worse, the results would probably be worse. And we see that we have some overshoots in here in the corner. And basically, yeah, this is the result of DVS check. Okay, let's go directly to the next step, which is optimization tool, which gives you an opportunity to select the code, to select the parameter, the part of the model, and to select the variables of different cross sections to run the optimization and to find the optimal cross section for your model based on checks result. This model, demonstration will be made in ANSYS. So we do have in here a model that represents kind of a jacket structure with let's take a look on that, with different cross sections, and I have already prepared the AISC standard, and I made an overall check of AISC, and I do have some overshoots there. So usually with a standard SDC Verifier workflow, you add a standard, calculate your structure, and see that some I've already selected the beams I would like to preview, but let's show it on all entities and select preview. So we do have some overshoots according to AISC in this standard that we would like to avoid. We have a maximum value of 4.86, but plenty of overshoots in here on top. And we can see, we can take a look on table. For example, we can add a components table, select the components from list, select all of them, and preview the overall utilization factor and see in the table which components of my model are not passing the rules of check. Let's start with the first one. Let's start with the horizontals. We see we have an overshoot in bending and axial combined with bending, which results in 1.37 value of the utilization factor. So let's take a look on that horizontals again, the same plot I showed you before. You can select this component here and select the horizontals. Take a look on this plot to see what is that. This is an I-beam. I already remember that. So this is kind of an I-beam which has an overshoots in connection here of 1.37, and we would like to avoid that. First of all, let's recreate that property plot which we had before to see which shape of that it is, because we see here IPA 400, IPA 300 we have, IPE. So let's make a colored plot of properties. Just right click on properties and select colored plot. Select all of them and press preview. And it gives you a better understanding of what properties you do have in your model. Takes a second to prepare this plot, and now we have a property like this. We had problems in this beams, which I assume is IPE 400. So we have an IPE 400 beam which is not passing the check. Let's add the optimization. So the new item that appeared in the menu is optimization over here. Right click on optimization, select add. Now we need to define what we would like to optimize. So we press on add, we select the load. So you can select any individual load, load set, or load group for optimization. But also it's, usually it's best to select the overall load group to see the maximum envelope result. Then here we need to define from which standard, which check, and what parameter you would like to optimize. We have so if we have only AAC 360 here, but if we prepared more standards in our SDC Verifier project, they will all appear here, and you will be able to select from different standards, and you able to optimize the different checks. We would like to make an optimization based on overall check results and parameter utilization factor overall. So we added a parameter that we want to optimize. Now the variable on which we want to make it the most effective. So we want to make it the optimization based on cross-section area. And we have to define minimum value. One more thing. It's not in here. Okay, so now let's select the shapes to be optimized. We want to have a component horizontals to be optimized, and then select a shape which is IPE. Here is a library of different shapes, so you just add the shape, and here you have a filter, so you're able to select IPE and go over a library of different IPE beams. We had, if I remember correct, 400. So let's do 450, 500, IPE 550, 600, and just for check, let's make 360. Maybe smaller shape will give us better results. We select this. So these are the shapes we're going to run for optimization. If you want, you can also define yield and Young, but it's not necessary in here because we optimize by area. And the rule is done. Press OK. The only thing I would like to, basically that's it. So what we have to do, we have to press calculate, and let's see how much time it will take for this optimization. Once again, we have not extremely big model, but quite extensive with about 15 different properties, and I assume about 10,000 of finite elements. And we made this optimization on 5 different cross sections. So it will also depend on the amount of cross sections. Over here, you can see which one is being calculated right now. So the optimization time depends on amount of loads that you selected, on the check itself, on amount of finite elements within your FEA model, and the amount of shapes you selected. The fewer shapes, the quicker it's going to be. But you see, it's quite quick. Well, picking that by hand and recalculating every time any way would take you much more time. So we did this optimization, and it already has results. We select it, and we can preview optimal result or all the results. So original model had an utilization factor in these members of 1.14, and IPE 360 will give us 144, and here all the other beams more than IPE 400 gives us smaller results. So you can review the shapes that you have available that you know are possible to be used on the construction site, and pick any of those, or pick the best optimal one, which is IPE 450. And after that, select change the beam shape. You select change the beam shape, and it asks you for a confirmation to add this cross section and apply to bodies in ANSYS. It creates a new, it created the IPE 360 because I haven't set the rule for optimization. We need also to define over here a limit on which we want to optimize. So I haven't defined any limits, and it took me the smallest shape as optimal. But what I would like to have is below minimum and below the value of utilization factor value of 1. So if I define this, it will treat the IPE 450 as optimal value. I'm not going to recalculate because we are already half an hour into this demonstration, but this is the general idea. You can run the optimization on any check you have. You can run it with different shapes. You can run it with your custom library, which we are going to add, and you basically don't need to recalculate multiple times now. You don't need to pick this shape by hand or just guessing. You can run the optimization with multiple tools, with multiple shapes, and just pick the best one for you. And of course, I just selected the one horizontals cross section, but it's also possible to add the same for the full model and run the optimization through the complete model. Just to save time of this demonstration, we optimized only one member. So basically, this is the feature which we are very happy about, and this is the major update in this release. I see the question from Michelle, do we need to define the section before optimization process? Yes, you do have to define which check you would like to run, so which parameter you have to optimize. And you have to define which selection you are going to, so what you are going to optimize. So in here, in selection, you select what you're going to optimize with components condition, with components from list. You can select horizontals to be optimized, or you can select all the entities of the structure to be optimized, or you can select a certain material from the list to be optimized. We actually have only one. Or you can select, this is based on force, you can select even by one element. So if you need to optimize one element or few elements in the connection, you can run that. So you can create any custom selection and run the optimization for this. You can run all model, then define the shapes you would like to optimize, and and run the tool again. I hope this answers your question. Yeah, Michelle is writing that because it seems that only sections defined in the model was used. The sections, the parts of the model which I would like to verify was used, and the sections defined by me were used. So you can, from this selection, you can run any. So I just selected this to save time. I just selected 5 IPEs, but you can optimize it based on full library and run it for 400 shapes. It will take you maybe half an hour or so, but you're able to optimize on those. Okay. basically that's it for the optimization. I'll show you a few more news in here, and we'll continue then to Bogdan. He will show you also the automation we developed in SDC Verifier. So we have a completely new report designer. It's also something that will that has a very different design to those who already get used to SDC Verifier and to reporting in SDC Verifier, but now it's presented in a bit more modern way, and we believe it's more convenient for the user. So this is a new interface. Let me show it to you in the program. So start is always the same, add designer, let's add empty. So you might remember that before we had a report structure here on the left, and we had a model tree on the right, so you could drag the items you would like to have to your report structure. Now we introduced the ribbon on top, which gives you a full control over the report and gives you an opportunity to add only those items which you would like to have. So on first one, on Home tab, you have a Save Project button, you have an Export, Generate, Open Everything, Report Structure, First Page Layout, and so on. So you can define, this is a standard first page we define for SDC Verifier project, but I assume every company has its own. You can define it here. You can define the number formats and settings for the legend and views and components and so on. On the second tab, you can include some items like preface, table of content, and model setup. So, for example, you can add the full model setup chapter or only materials description, only properties, components, and so on. So everything what's been here in model setup items, now it is in model setup over here in the Insert tab on Ribbon. And here you also can create the user chapters, you can add text, images, plot of models, and customize your report. Then the main tab of presenting the results is Results tab. You can add a table here, and you can add plots, beam member diagrams, and check results immediately. So before, checks were in the same group, so all together grouped under a check tab. Now everything is going to be sorted either by loads or by selection. On the Home tab, you can define it in report structure. So do you want to result the group results, or do you want to group the results over loads or over selection? We select loads. And then if we go to results and we want to prepare, let's say, a table, stress table, here we select the loads we would like to have. I want to show a complete detailed report to my customer, so I select all the loads, all the load combinations and load groups. So we have 11 selected loads. I want to make it a stress table, extreme, just to show the maximum stresses, and short to keep it short and readable. I select all entities over here and press add, and then the job is created, and for each the load, the stress table is created. I can do the same with the plots, so I can create a criteria plot, select all, stress plot with the default view, equivalent stress, total on all entities, and press OK, and I added a plot. So with this few clicks, I prepared a complete report with presenting the stress results on all of my loads for the customer. And now if you add a check, we have only AASC in here. You can add the check in the same way. So you basically select the overall, and we want to make a check table. I select all individual loads, load sets, load group. I want to show extreme utilization, extreme table for the utilization factor on all entities. Press OK. Press OK, and now the check results are added under each load. So we have stresses, and then we have AISC results with tables and with plots. This is basically the main change of the structure. And also multi-select is finally available in SDC Verifier, so you can click and select multiple items and then add them, remove them, copy, apply to them some standard rules. For example, you want to break page before these items, you execute right click, apply to selected, and then break page before yes. Before each of these items, each of these items will start on the new page. So one more item on the ribbon is post-processing tab, where we can add big finders and governing loads and free body tools, so our post-processing tools. And import, which is very important. To here you can add results which were created previously in the main window of the program. So we were making the table over components, or we were making a check plot. We can add this to the report structure in the end as well. Here it is. And also here you can add the part of the Word document. You can add some external files. So you can import already a part of previously prepared document. So this has a lot of change visually, but in general, it's a good old SDC Verifier report designer with new features, with multi-select, with the possibility to have more control over the structure of your report. I'm going to save it. And a few more things I wanted to show you very quickly to give the floor to Bogdan. One more thing added is the comparison standard. Sometimes user asked us to have a possibility to show the maximum result over different standards or compare the standards. Now you can create in the standard the comparison, and it will automatically create an absolute maximum of results of both standards. So you can create Eurocode 3, you can create AASC, then make a comparison and show the overall maximum of both standards. So if it's important to the customer, for example, or for you to have very conservative results and the worst possible, you can show the worst utilization factor of few standards. So this is kind of a comparison of the standards results. There is one change in formulas. Before infinity or division on 0 or not a number were marked with 0, and that could affect the results of the calculation. So in this version, if in formulas anywhere or in the check there is going to be a division on 0 or not a number, it's going to be replaced with a huge number close to it was an infinity number, which will show you very big results in your table, and the warning like this will be shown. That means that you need to check the formulas, and somewhere in your formulas you have a division on 0. And the next part is SDC Verifier API, which I would like my colleague Bogdan, who is the software developer here at SDC Verifier, to present. So Bogdan, I'm giving you the role of presenter. Now you're able to share your screen, and yes, you're changed to presenter.
Okay, so I should share the application or the screen, because I forgot.
Doesn't, if you want to show, better screen if you want to show both slides and demonstration.
Okay, I will share the application. Okay, is it visible now?
Wait a second. Yes, now I see your window. Okay.
Yeah.
Okay. Okay, so but before the automation, I would like to show also some other improvements that we prepared for this version. And for the reference, I will use this part of the ship. And the project was already predefined settings. So I would like to start with Welds Finder. So what we did here, we did two functionality. First one is it is possible to add multiple welds by nodes. So before you could only add like by this window, and you had to pick only one row of the weld elements for the one weld. Now it's possible to pick that with the multiple. I will show you. Okay, pick front. For example, I want to add a weld here, and here, and here. And after I press OK, so at the end, I will find my 3 welds added to this selection. I will just preview them in the colors to see. Yeah, and you can find it here. Another thing, it's you can recognize the weld on any custom selection that can be different than defined in the settings. Because in the settings you can reduce your selection, or you can use not all entities. Yeah, and for this purpose, you can find not to change the selection back in the settings. You can find the extra welds on some defined selection. For example, if you imported a part of the model to your structure, or you did new modeling on that, so you can pick that part here and just recognize the extra welds. I will try to do that with the all settings. We will see that now we have 1,700 welds, and if you go now till the end, we have it doubled. So all the welds created before remain to be in the list, so they are not removed. Okay, that's it about here. Next thing I would like to show is in Panel Finder. We added two extra settings. So one setting is angle between flat plane normals. It is used when, for example, you have this option like coordinate deviation. If you set, for example, here 1, and in your model, I will scope to the part of the ship. And for example, if we recognize section on the constant coordinate on X. The coordinate deviation means, for example, if you set 1, it can pick these elements from this area. The angle between flat sections will only keep you all the elements that are directly on this row. On this and on this. And if you have some inclined elements, they will be skipped. So that is this option. Another option is to when some stiffeners are not modeled completely, they do not touch the panel on the both edges. Before, in previous version, this was not recognized as separate panels. This one, and this one. Now you can control the option. So, for example, if your stiffener covers your panel more than let's say 80%, like here, it will recognize automatically the dummy stiffener, and it will create like a border here. It means that it will be used to split this panel on the plates. So this will be a separate plate here and a separate here. And if you say to cover that more than 66%, like in this case 2, it will split both. So this is going to be a separate plate, this one and this one.
Yeah, this is a very important feature because for those who model the ships, the stiffeners were not directly touching the other sections or longitudinals or girders, and it was a problem because then you had to create some dummy elements, or you have to define manually how to split, or you had to do some extra work if your stiffeners were not completely 100% length from node to node. Now it's possible to define the percentage of the length, and if, like on this picture, 80% of the length is covered with stiffeners, and it's going to be treated as a stiffener along the full panel and split this panel.
Yeah, thanks, Oleg. Okay, I will show you that for one section. So for section 5, I will plot all the panels in colors. And then I can draw the dummy stiffeners recognized from the setting here. I'll show also fillet edges. And you see here, you can find that stiffeners recognized like drawn on the model. So this stiffener covers more than 50% of the panel here, and it was like lengthened to the end of the panel. Okay, next what I would like to show you is custom check table.
Yeah, Bogdan Boss was asking for a demonstration. It would be nice to see afterwards which panel have been splitted with using this wave of recognition. But
Okay.
you just maybe if it's not going to run very long, it's nice to show it's that if you activate this option, it's actually splitting the panel.
So, he meant about the results of backlink check, or just to show the
I think
plates?
just plates will be enough for now.
Okay, we can plot that here. We can plot the plates. So it used to be somewhere here.
Mm-hmm. Yeah, you can even see that the angle is it's not completely straight. That's probably yeah. Okay, thanks.
Okay, so let's get back to the custom check table. What we added here is filter and sort by options. So before we had that for join checks, for plate buckling tables, but now it's expanded also for the custom check table. So it's available only for expand table type, and you can set some filtering. I already have that, so I will filter that for overall direction and sort in descending order. So I will press the fill table to watch the results. So as you can see, we have the sorting so that the maximum value is on the top, and all the values above 0.8 are filtered in this table. Okay. Next, what I would like to show is the flow table for plate buckling check. A big change of here is that it can be built on any custom selection. You can preview result for any element, even one element from the model. Before, you had to pick only one section recognized in the panel finder. So I will fill table to see the to show the structure, and see, here we have the two options. You can build that table over loads or selections. So now I build that over selections, and you can find each selection here contains the results for all my selected loads which pass the filter. So with the values about 1 for the overall buckling factor, we have this displayed. If we build that over the loads, it will work in vice versa direction, so it will show you all the loads and all the selections under this load that pass the filter. Okay, let's move to the next improvement, peak finder. So in peak finder, we added extra option to prepare a range of the results. So before you could only set it above 1, for example, or above or below 1, and now you can add a double condition, for example, above 1 and below 2. Also in the peak finder table, if you go here, for load groups, if you find the peak zones, if this zone is based on the load set, we can preview the content of the load set. It means that it will show you the results of all individual loads on the included in this load sets multiplied by factors, and you can show that in, for example, diagram. So it looks like this. So you have here you can see the result of the load set. This is first one. And all the results of individual loads, and you can directly preview which individual load has much influence on in this load set. Same, you can preview that with the table, so you can find here. So you have the result of the load set here, and the result for all individual loads multiplied on factor. I have here 1, but if you have that more, then yeah, the values will change, but in summary, it will show you the same result as for load set. Okay, next feature, we're going to governing load. Governing load now also can be built on multiple selections. Before you could check only one selection in here. So we have changed some interface here. So the limits criteria are located now here. You can also pick the range of the results you want to search the governing loads. And also we have a few options. We have the summary, so it will the worst governing load will be shown for each selection defined here. You can define all governing loads for each selection, or display the result for each element. So I'm going to display all governing loads, and here you can find that for each selection you can see the worst results. Also here you can find the amount of elements that this governing load produces. Same as in Peak Finder for load set, if you have the governing load as a load set, you can preview the content of the results. So it will be the same as from the Peak Finder. Okay, here I think that's it. And now I think we can show the SDC API. It can be found from this menu, automation, and SDC API console. So I think most of you are already familiar with what is API. So that is an automatic programming interface that allows you to interact with, in our case, with SDC Verifier, so you can automate your repetitive work in this window. This is the code, the script written here is can be prepared using the C# programming language. And to start scripting to access the methods of the SDC Verifier API, it starts always with SDC API. And if you press dot, you will get a list of the available methods here and descriptions for them. For example, we have a few types of the methods. So one, it returns the object. For example, get project. It will return you the object of the full project of SDC. So with all the info. We have a return type of the Boolean. It means that this will return if the method passes or fails. Or we have only void type. It means that it will not return any value, but just do some action. For example, SDC API exit will close SDC Verifier at all. I think I can show you a few examples of how to use that. For example, I want open project here, and I can see that I need to define the project file name. Actually, it is the full path to the project. So it's better not to define that here. You can define that here also as string, for example, C and so on. But you can also declare a variable. To declare a variable, you type the var, the name of the variable, and then you can specify the path of the file. For the path, it's important to use the @ symbol before the string. Okay. For example, if you forgot to what path you would like to use, you can close this window without the warning. The script will be lost. So, for example, I will take the path from here, copy that, and go back to automation, and I see that my script is still here. So I will insert the path here, and we'll just use that in open project. Okay, another option is to for SDC API get load set. You can get also individual load groups, and other types, and you can take only one load set you need, or you can take the full collections and you later want to iterate over it. So I will use the one load set. So here I need to define the ID of the job and ID of the load set. I have that 1 and 1. And we see that this method also returns the object of the load set. So I will use that as a variable, and load set 1 equals to this method. And also want to mention that each method should end with a semicolon, because then it will treat as the separate method. Next, what I would like to show is how to set the safety factor. Set safety factor, and we have a few options. We can have that we can pass this reference of the load set inside the method, or we can specify the IDs also, like here. I will use that for the reference. So I type here load set 1, and I apply safety factor 1 set to 3, for example. So this will change safety factor in my load set 1 to 1 set to 3. It is possible also to add standards here. So we type also SDC API and add standard. And you can find the list of the standards available. It will be created with default parameters, so you need to only thing you need to define here is a title. For example, I will add Eurocode fatigue, and here in the title I will type just Eurocode title. Okay. Next,
Bogdan, I think we are a bit running out of time. Maybe just explain so what is the general idea of this API is to automate your work. For example, if you want to run multiple reports with different conditions, or opening few models as template and then running the reports overnight, you can customize it, automate it, and run 20 reports, 20 calculations when you're out of office and SDC Verifier is still working for you. Or you can automatically define safety factors. You can run, you can basically automate a lot of features of SDC Verifier and save even more calculation time on that. Yeah,
the list of full methods can be found also in our help topics, so you can check that also there. So okay. I think that's it.
Okay, we are just into 1 hour. I just wanted to take this time to also, I think Bogdan, you can stop sharing. Okay. I just wanted to summarize everything. So what we've developed in here is automation and optimization. We added new codes, we updated our reporting, and we added plenty of new settings for the recognition tools, for the tables, and so on. So we already have a video recorded for optimization tool and for the new report designer. I will send you that recordings together with recording of this webinar. Once again, if you would like to try, you're free to request a trial or update your SDC Verifier to the latest version 2020. If you do have any questions and still have time, you can address them now or send it later to support@sdcverifier.com or to me or Bogdan directly. We will be happy to help you. And if you need another dedicated demonstration of any features shown today, for example, you want to see how optimization is running on your type of structures, we are happy to arrange a dedicated demo and discuss it with you separately. So I thank you for attending this webinar. I don't see any remaining questions. If I assume that most of them appear when you start using the program. So I can only encourage you to start using SDC Verifier more and then come to us with the questions. So thanks, take care, stay safe, and talk to you soon. Thank you.